Hi, I'm Carson Jacobson, and this is my first physics lesson. Please note this should not be your first physics lesson because some concepts ought to be known by this point in physics. Today we'll be using torque, tension, and a little bit of trigonometry, which is more of a math than a physics concept, but whatever, we're using it. But before we get to that, allow me to describe to you the problem. This is Billy. Billy owns a really tall house. Towards the top of his tall house, he has a patio that extends 10 meters. At the end of this patio, he puts most of his belongings into a box. Well, not most of them, but a pretty fair amount of them into this box. And he spends it there for no reason. He just does. Never uses them, but he doesn't want to throw them out, you know. We all have that kind of stuff. And that patio is supported by this rope, which is connected to the patio 3 meters from the wall and forms a 30-degree angle at the wall. Here's another one of Billy's hobbies, though. He likes to go out and stand on the patio and gaze over the city. Because it's fun. And since he's so high up, he feels like he's in charge, you know? But he doesn't know how far out it's safe to go. He does know, however, that his rope will break at a certain point. That point is here. Tension maximum, so maximum tension, is 4,149.22 newtons. So Billy would like to know how far out he can go before his rope breaks, sending his 100-kilogram self and his 50 kilograms worth of belongings down to the ground. It's actually a lot simpler than my math suggests, and I'll walk you through that. First step is figuring out how much torque the rope is supporting. Now, the torque equation is force times perpendicular distance, so we can't just use this value. Because what we're going to be doing is assuming the tension in the rope is already at its maximum and figuring out how far Billy would have to be to make that happen. But we can't use that value because the torque is acting in this direction on a patio facing this direction, which is not perpendicular. So we need to find the y component of tension and use that value to find the torque of the rope. Or rather, the torque that is being exerted by the rope. So this is done using some basic trigonometry. We know this angle measure is 30, so by drawing this invisible line here that represents the y component of tension, we know that this angle measure is 30. So, cosine of 30 equals the adjacent of the triangle, which would be the y component of tension, divided by the hypotenuse, which would be the tension in the rope, which is 4,149.22 newtons. From here, it's some basic algebra. You multiply the denominator value to the left side and plug that into your calculator, and you get tension let me restart that, and you get y component of tension equals 3,593.33. Please note this is a rounded answer. However, for any further calculations in which that number is used, I used the genuine value. From here we can start working with the torque. Torque is force times the perpendicular distance. So that would be this value, the tension in the rope, exerting an upward force, times 3 meters. And that gets us plugged into the calculator using the genuine value rather than the rounded answer, and we get 10,779.99 Newton meters. Also a rounded answer, again, genuine value used in calculation. Now, we know that it hasn't broken yet, which means nothing is rotating, which means the system is in equilibrium. So the sum of all the torques equals 0. From there we can set up our equation. 0 equals the torque exerted by the rope, 10,779.99 Newton meters, minus the torque exerted by the box, 50 kilograms times acceleration due to gravity of 9.8 meters per second, times its perpendicular distance, 10 meters, minus minus the torque of Billy, which is 100 kilograms times 9.8 meters per second, times unknown distance d, which is what we're trying to solve for. The reason it's a minus is because it's acting in the opposite direction. The rope is acting in a torque this way, everything else is acting in a torque this way. From there, you multiply everything out as much as you can out in your calculator, and you get 0 equals 10,779.99 Newton meters minus 4,900 Newton meters minus 980 newtons times our unknown distance d. From there, I did multiple steps at once to get a nicer equation and maintain room. And that gave us, well, let me tell you what steps I did before I tell you what we got. First, I subtracted this value over to the left side. Then I added this value over, and then I multiplied the entire thing by -1. So that gets us 5,879.99 Newton meters equals 980 newtons times our unknown value d. From here it's simple algebra. Excuse my sister there. She's leaving now. From there it's some simple algebra. You divide this value. Actually, you divide the unrounded value by 980, which leaves us with the value, it's actually 5.9999 something, which I justifiably rounded to 6. So, we know that Billy can safely get close to 6 meters away from the wall without the rope breaking. Thank you for suffering through my video. If you could leave a nice like on the video.
And hit the bell.
Yeah, go ahead and hit the bell. That way if I ever produce a new video, you'll know. Subscribe to my channel, yada yada yada. You know the stuff. If I made any errors or explained something poorly, leave it in the comments and I'll be happy to reply. Thanks for watching. Bye.